Today, I want to show a few examples of differentiating implicitly, okay? So let's start with this one, right? So we want to take the derivative of the entire thing, right? So here we're going to use the product rule. So the derivative of x is 1, right? Then times this, which is y prime, plus, right? Then you have x times the derivative of this. Now, when taking the derivative of y squared, you have to be very, very, very careful, right? You might be tempted to treat it like we would treat x squared, where you just use the power rule and you're done. But you can't do that. We're treating y like a function, meaning we have to apply the chain rule, not the power rule, right? Well, we will apply the power rule, but in the larger scheme of things, we have to apply the chain rule. So what is our larger function? Our larger function is something squared, right? Y squared. So we start by using the power rule, so we get 2y, but we can't just stop there, because that's our larger function differentiated. Now I have to differentiate our inside function. Our inside function being y, right? And the derivative of y will be y prime. Then we have plus, then we're going to use the product rule on this, and we have 2x times y, right? Then plus, then x squared. Sorry, that's x squared. Now, all we have to do here is just make this y prime. There's no chain rule to use. Times y prime, and then this will equal 0, right? Derivative of 6 is 0. So let's just rewrite this a little nicer. Plus 2x y prime plus 2x y plus x squared y prime equals 0. So then what we're going to do is we're going to put all of our parts with y prime on one side and all of our parts without it on the other side, right? So what we end up with is 2x y prime, so that's squared, y prime plus x squared y prime equals negative y squared minus 2xy, right? Then, I'm not going to show this part, right? But I'm sure you can visualize it. What we're going to do is we're just going to factor out y prime, because both these terms have y prime, so we can factor it out. And then we divide by the part that y prime is being multiplied by. So we get y prime equals negative y squared minus 2xy over 2xy plus x squared. All right, and this right here is our final answer. This will be our y prime. So we have successfully implicitly differentiated this function, all right? This equation. So then let's do another example, but this time let's differentiate it twice. We'll work with a little bit of a simpler example just to get the hang of it. We'll do x squared plus y squared equals 1. Okay? And we're going to differentiate this twice, right? So we're going to find y double prime. So we just start with differentiating the entire thing. And you get 2x plus, and then once again, with differentiating, this is the most important part of implicit differentiation for you to pick up on. When differentiating a y, you can't just treat it like you would treat an x. You have to treat it like you're treating a function, right? You can't, in other words, you can't treat it like a variable, you have to treat it like a function. So we apply the chain rule. So you have 2y times y prime equals 0. Then, once again, we get 2y prime equals negative 2x. Then we just we can just divide by 2y, and we get y prime equals negative 2x over 2y, right? And I'm sure you can see we can divide by 2, and we get y prime equals x over y. And if we just wanted to differentiate it once here, we'd be done, but we're not done, right? We want to differentiate it twice. So we differentiate it, and we get y double prime equals, and here we're going to use the quotient rule. We get negative, then denominator squared, y squared. Then we get derivative of the numerator, which will be 1 times the denominator, y, minus, then numerator times derivative of the denominator, which will just be y prime. Okay? So what you end up with here is negative y minus x y prime over y squared. Right? Hopefully you can see that. So what we're going to do here is we already know what y prime equals. Y prime equals that. All right? So what we do is we come down here. We get, we'll say equals. Then we have negative y minus negative x over y, then y squared. All right, sorry, this is also times x, right? So then we're going to multiply the entire thing by y. And we get y squared plus, because it's double negative, so it'll be plus x squared over y squared. Now, you might just stop here, but we wouldn't be correct in doing that because we can now come up to our original equation, right? And we can write it in the form x squared equals 1 minus y squared. So we now know what x squared equals. So we can write this as y squared minus 1 minus y squared, or sorry, plus, right, over y squared. And these two y squareds will cancel out, right? And sorry, let's not forget the negative. I almost forgot the negative, right? And we end up with negative 1 over y squared. Oh, I'm so sorry. I made a mistake. Sorry. So what we want to do, right, we multiplied the entire thing by y, but I forgot to include the denominator. So this will be y cubed. Yes. So there we go. That is our final answer. Or if we want to, we can write this as negative y to the negative third, right? So there we have our final answer. Thank you so much for watching. Let me know if I said anything wrong. Have a great day. Bye.